Hello and welcome to our introduction to Git and GitHub. What I'm going to cover today is kind of the basics of both Git and GitHub. So covering things like what is Git, what is GitHub, what are they used for, and then we're going to go over kind of some basic commands and basic kind of workflow and things that you can do with GitHub when you're first getting started. So the first thing that I want to discuss is what is Git. I think a lot of times there's a misconception that Git and GitHub are the same thing, and they're actually not. So what Git is a distributed version control system. What a version control system is a system that allows you to track the changes of a file over time. So if you use something like Google Docs, or if you use Apple's Time Machine backup software, you've maybe seen a product that does something like this. What Git does is basically the same kind of thing, but instead of for files or Office documents, it does it for any kind of text file. So it's traditionally been used by computer programmers for computer software, but you can use it to track the changes of just about any piece of text. And the way that it works is as you make the changes, it tracks those changes over time, and it stores those changes so that at any point, if you want, you can rewind to a previous version of the file. And this is extremely useful for software developers because a lot of times with software, you're editing things and kind of changing the software iteratively, and you get to a point maybe where something doesn't work, and it's helpful to be able to kind of rewind to a previous version of the software. So Git was developed by Linus Torvalds in 2005. It was developed for use with the development of the Linux kernel, and there were other version control systems available at the time. But the Linux kernel had become, at that point, a really complex project. There were a huge number of engineers working on the project simultaneously and simultaneously making changes to the code base. And so they needed a kind of more sophisticated version control system that was able to handle that amount of activity on one piece of software. So what is GitHub? So GitHub is a company that was founded in 2008. And originally the purpose of GitHub was to provide web hosting for Git repositories. And so when we talked about Git a second ago, a repository is the file that stores both your text file and all the changes to that file. So it's all stored kind of in one package called repository. So originally GitHub's purpose was to provide web hosting for those repositories. So if you were working on a piece of software, let's say, and it was stored on your local machine, on your laptop maybe, if you were backing it up to GitHub, even if your laptop got run over by a bus, you would still have not only the piece of software that you were developing, but also all of the kind of rich history of its development, which could be useful later on down the line. And there were a lot of other companies that provided the same kind of web hosting for Git repositories, but the thing that made GitHub fairly unique was they built an additional layer on top of the web hosting, which was a layer of social networking features. And so they allowed you to follow other developers, they allowed you to follow projects, they allowed you to star projects, things like that. And this actually became really popular because developers, especially open source developers, love to follow each other's projects, love to work with each other, love to kind of follow people that they might want to work with later on down the line. And so those features were kind of a natural fit for that community. So as a result, GitHub has grown a lot in just a few years. They now have over 3 million users and over 5 million repositories hosted. So why should you use GitHub? So like I said, it's an online backup for your version history, which is very useful. But it goes beyond that. So it provides you the ability to collaborate on projects with multiple developers all at the same time. They have a lot of tools that make this easy and kind of facilitate this model of development. So even if you and I, let's say, edit the same line in the same file at the same time, it has kind of a mechanism and interface for going through and deciding whose change we want to keep and whose change we want to reject, or if we want to merge both of those changes and come up with some kind of compromise. So things like that. The ability to easily fork existing projects. I'm going to talk about forking in greater detail in a bit. But essentially, you can take a project that's on GitHub, you can take that code base, you can use some of it, you can use it as a springboard for a new project, you can kind of repurpose the code in there. And that goes into the next point here, which is that GitHub is a social platform for discovering the work of millions of fellow open source developers. And the important part of this sentence is the open source part. Essentially, all of the software on GitHub is open source. People wouldn't put the software up on GitHub to begin with, generally, if they didn't want others to use it and they didn't want it to be open and available. And so, it's still good practice to always read the license of every piece of software that's on GitHub. Not all open source licenses are the same. It's always a good idea to know what you're allowed to do and what you're not allowed to do. But generally speaking, if a piece of software is on GitHub, you can usually pull it down, make some changes to it, repurpose it, reuse it, as long as you're doing so within the terms of license. So this is what a GitHub profile page looks like, and I picked Daniel Schiffman as the example here because he is extremely active on GitHub and has written a lot of pieces of really great software that a lot of computer programmers and developers use. And this is, generally when you land on someone's profile, this is like looking at someone's, profile page on Facebook or on Twitter or something like that. This is kind of Daniel Schiffman's home on GitHub that details all of his activity. So there's a few things here I want to point out to you. The first one you'll see here is, in the lower left corner, there are kind of basic stats about Daniel. And so it's got his number of followers, the number of repositories he's starred, the number of people he's following, and then the organizations that he's a part of. So in this case, ITP and the processing team. And then if you look up here, these are his repositories. So these are repositories that he himself has created and put up on GitHub. If you look just over to the right there, you'll see repositories that he contributes to. So these are repositories that somebody else has created that Daniel is contributing changes to, making suggestions. He's somehow involved in the development process on these, even though he didn't create them. And then if you look down just below that, you'll see the kind of activity graph. These are his commits and contributions over time. So each square on that grid is a day, and the shade of green tells you how much activity took place on that day. So the darker the shade in the square, the more activity on that day. So you can kind of see there are, areas of activity and then areas of inactivity as well. On the previous screen, we saw two different types of repositories, the repositories that Daniel had created as well as repositories that he contributes to. And if you click on any one of those, you're going to end up on a page like this. This is the kind of repository page. So this is kind of the home for a repository, and within that repository there might be a number of different folders and a number of different files. I want to point out a few things to you on this page that I think are useful. The first one is the kind of top navigation bar that runs along the top there that tells you a lot about the activity of the repository, so the number of commits, the number of branches, number of people who are contributing to it. Over here is a really important button. This is the fork button, and if you want to fork this repository, this is the button that you would press if you're signed into GitHub. So before we go any further, what is forking? So one way to understand forking is to look at this road sign, the fork in the road sign, because I think it's fairly useful in this case. And if you imagine that road at the beginning, the single road, that's a piece of software. And at some point, somebody else decides to take that piece of software and make a change to it and kind of take it down a different path than the path that it was already on. So it creates this kind of fork in the road. You have kind of two roads, right? So you've got the original piece of software still going along, still kind of continuing to be developed in the original mode that it was being developed in, and then now you have this second branch that maybe is slightly different, maybe is adding new features on, subtracting features, taking the kind of original software in a new direction. The interesting thing with software development, unlike the actual fork in a road, is that sometimes the forks merge back into the main road. So sometimes if somebody takes a piece of software down a different road, they make some changes to it, they might decide, hey, I was looking at this piece of software and I figured out a much more efficient way of doing this specific thing, and I think this would be useful to the person who originally developed the software. I think it would also be useful to all the other people who are using this piece of software or following the development of the software. So there's a mechanism in GitHub called a pull request that I'll go over in a little bit that allows you to take any change you made that you think is useful and make an attempt to contribute it back to the kind of original mother branch of that software. And then at that point, you can have a conversation with the original developer about whether that change is good or not, and they can decide whether they want to merge that into the original branch, or if they want to continue on the existing development path without merging in those changes. And so here behind the road sign, you can see the GitHub network graph viewer, and this is kind of the GitHub version of the fork in the road sign. So this is for a popular piece of software. You can see the master branch at the top, and a fork that comes off of that, and then a fork of the fork, and then a fork of the fork of the fork, and so on and so forth. And you end up with these really big kind of complex trees of development where sometimes the changes that are made down the line of 1.4 get merged back into the original. And GitHub has a lot of different tools and visualizations for helping you understand and visualize these things even when the development process gets very complex. So there's a lot of different people involved. So going back to the repository screen over here on the right-hand side, there's a sidebar, and this has a lot of information about what's going on right now with the repository. So you can see things like issues and pull requests. These are basically like the number of open issues, the number of suggestions that have been made, problems that have been identified, outstanding issues, that sort of thing. Down here you can see the clone URL. We'll get to that in a minute. It's very important. And then at the very bottom, we've got the README. And for my money, this is actually probably the most important thing on the page, because when I first land on a repository page, the first questions I have are, what is this piece of software? What is it used for? What kind of technologies do I need to know as a baseline for using it? And what kind of documentation is available? And the README is where you're going to start to find all of that kind of information. Generally, there's a description that says, this is what the project is, these are the technologies I've used to build this project, here's the different things that you need in order to get up and running with this. Maybe you need some libraries or something like that. You need to have something installed on your machine. And then a lot of times they'll have, whatever documentation will either be in the README or will be linked to from the README. So you might have an FAQ or a getting started guide or an installation guide or something like that that can help you get up and running. And so a quick look at the README will usually reveal pretty quickly whether this is a piece of software that's going to be useful to you or not, and whether or not you have the skills necessary to use this, or if you need to find something else, or whether or not it's the right tool for the job, basically. So we've talked a lot about GitHub theoretically, but we haven't really talked about the nitty-gritty and the kind of mechanics of how this all works. And so I want to go over some basic GitHub commands because I think they're useful, and whether or not you use the command line, these are the kind of core concepts that you'll need to understand to use GitHub in any of the ways that you choose to use it, whether you use the client or the command line. So the basic thing to understand here is that the GitHub repository is something that lives in the cloud, right? It's something that is living on GitHub servers, not on your local machine. And your machine, is over here on Earth, as we see in the diagram, so to speak. So what we need to do is we need to connect your machine with this repository that lives in the cloud. And there are two ways of doing that. The first is using the terminal or the command line, and that's kind of the traditional route of using GitHub. I'm going to show you how to do that just because I think that is a good way to understand the fundamental concepts of GitHub. But there's also now something called GitHub for Mac, which is an official client that's developed by the GitHub team that allows you to do, basically 90% of what you would do in the terminal. They both kind of share the same language, and they both share the same concepts. And so I'm going to go over the concepts as if we're going to use the terminal, but really you could use GitHub for Mac and do a lot of the same things. So I'm going to go over some basic Git commands. These are going to be like kind of the top 4 commands that you would use the vast majority of the time if you're using GitHub, no matter what you're using it for or how advanced you are. And the first and most basic one is called push. And so the idea here is when you have a repository that lives in the cloud, that's going to be basically like the master copy of the software, right? So you're going to have this piece of software, and you're measuring or comparing all the other pieces of software against this one to figure out how something has changed. And so let's say you have changes on your machine that you've made that are not yet reflected in the GitHub repository that lives in the cloud. What you need to do is you have to push those changes from your machine up to the GitHub repository. And within that push, there's a number of kind of different commands that you need to execute leading up to the push. So you need to do an add, and you need to do a commit before you do the push. The add is basically telling Git what files you want to be included when you're pushing these changes up there. So sometimes you want to just add the changes you made to one file. You're not ready to add the changes you made to another file yet. So this is a way that you can specify that. The commit kind of does 2 things. One, it commits the changes that you've made. So it's kind of like a "Are you sure?" dialog box, something like that. But it also allows you to leave yourself a note. And then finally, the git push is when you're actually pushing the changes that you've added and then committed up to the GitHub repo. And for each of these, there's subcommands. And so for git add, you can type in the file name after that and just add a file name, or you can do git add space period, and that will add basically all of the files in that repository. And so if you're agnostic, you don't really care if you just made changes to one file, let's say, and you just want to push the whole thing up, you can just do that, and it will only upload the files that have changed and ignore the ones that haven't changed. Git commit -m is a really useful command. The -m basically tells Git you want to leave a comment on the same line as the command, and the comment is basically like a note to yourself. So think of it like you're leaving a trail of breadcrumbs as you're developing this piece of software. Each time you make a change, you're leaving yourself a note, and you're telling yourself, this is what change I made. And at the time that you're doing it, it may not be apparent why it's useful, but as you're going down the line of developing a piece of software, you're inevitably going to get to a point where something breaks and you can't figure out what went wrong. And you're going to say to yourself, well, everything was working right before I made that one change. If only I could dial things back to that one change, I think I could figure out where things went wrong. And so if you've left yourself this kind of trail of breadcrumbs with your commit notes, then you can just go into your commits and see, oh, okay, that's the change that I was looking for, and you can just rewind the clock to that change. And this is it's an extremely useful thing. It's hard to conceptualize when you've only made a few commits to a repo, but if you've been developing a piece of software for a really long time and you've got hundreds and hundreds of commits, it makes it much easier to kind of quickly scan through those and figure out which one you're trying to find. And then finally, git push origin master. That's just telling it where to push the changes to. In this case, you're pushing it up to the GitHub repo, which I said is like the master copy, essentially. So that's what the origin master means. It's basically saying, push this up to the master copy of this repository. So the next command I want to talk about is called pull. It's basically the exact opposite as push. It means that if there are changes made in the GitHub repo that do not exist on your local machine, you want to pull them down from the repository. If you're developing a piece of software with yourself, maybe the only time you would use this is when you are first getting started and you create a new repository on GitHub and you want to pull that in. But later on down the line, if you're working on that piece of software and somebody else joins you and you're both making changes to the software, there may come a time where somebody else makes changes and pushes them up to the repository, and then you don't yet have those changes on your local machine. So pull is a great way to pull in whatever changes somebody else has made to the repository and kind of stay up to date with the latest version of the master. Clone is very similar to pull, but pull is only going to pull in the files that have changed. Clone is going to pull down all of the files all at once. And so clone is really useful if you find a new project on GitHub and you just want to pull the whole thing down all at once and just start looking at it, start hacking with it, that kind of thing. And again, when you're first getting started with your own repositories, people often use the clone command just to pull everything down so they can start getting started on their machine. So the last kind of command I want to go over is called a pull request. And it's a little bit conceptually difficult to understand, more so than the other ones. But bear with me. Hopefully after you have tried this a few times yourself, you'll get the hang of it. But it's confusing a little bit because of the name. So the way that it works here, you see we've got the computer on the left and the computer on the right. And the computer on the right has a fork of the repo, right? So the computer on the left has created this repo. They've added all this stuff to it. They've pushed it up to GitHub. The computer on the right has downloaded that repo. They've forked it. They've started making their own changes. And they've made a change that they think is a significant contribution that they want to contribute back to the master branch. And so a pull request is the mechanism by which you do that. It's called a pull request because what's happening is the computer on the right is inviting the computer on the left to pull in its changes. And so the computer on the right has those changes. If the pull request is approved, those changes get sent over to the computer on the left. And then when the computer on the left pushes those changes up to the repo, then they get merged into the repository. And so the pull request is kind of the mechanism, when I was talking earlier about forking, pull request is the mechanism I was referring to by which changes that are made on forks later on down the line of development can still always be contributed back to the master branch. So now that we've gone over all those basic commands and hopefully you have kind of a fluency in what all of those commands mean, I want to jump out of the presentation really quick and do a demo. So what I'm going to do is I'm going to log into GitHub, and I'm going to start on the GitHub homepage here. And up here in the upper right-hand corner of the screen, there is a button that says Create a New Repo. It has something that looks like a book and a plus sign on it. So I'm going to click on that. And this is how I usually get started if I'm creating a new project. So I'll go in here and I'll create a name for the repository. We'll call it test repo. All right, that looks good. And we'll say this is a test repo. Good. So you can choose here between public and private. I'm going to choose public. Most people choose public. Private is really only used if you're creating a piece of software, for commercial use or something like that. You don't want anyone to see it until it's released. But I'm going to go ahead and keep public. And I'm going to check this box here to initialize the repository with a README file. So GitHub is going to create the README file for me automatically, so I don't have to do that. So I'm going to go ahead and click this button that says Create Repository. It's going to take a second, and there it is. It's created our repository. So we've got our repository. Here's the title. You can see it has a README. The README is the only file in here. This all looks good. So what I'm going to do now is I'm going to grab this clone URL that I was talking about earlier. I'm going to copy this into my clipboard. And now I'm going to go over and launch the terminal. And when I go into the terminal, the first thing I need to do is, let me increase the font size to make it easier to see. So the first thing I'm going to do here is I want to go into the folder where I'm going to keep this piece of software that I'm developing. So the Unix command that you use to do that is called cd. Cd is what you normally do to move into a folder. What you normally do here is you would type in a file path. But one of the nice things if you're using Mac OS X that you kind of get for free with the operating system is you can do drag and drop directly into the terminal. So that's what I'm going to do just to make things easy here. So let's say, let's go into here, create a new folder, call it test2. Okay. So create a new folder, and what I'm going to do is I'm just going to drag this folder directly into the terminal. You'll see the terminal will create that file path for me, so I don't have to type the whole thing in. So I hit enter, now I'm inside the folder. The first thing I need to do here is type git init. And what git init does is it basically initializes the folder. It tells Git, this is a folder that I want you to start tracking the changes on, start tracking every change that gets made to every file that lives inside of this folder. So I go ahead, it has initialized the repository successfully. So now I'm going to type git remote add origin. And what this is doing is basically saying, all right, from now on, the master copy of this folder is not going to be, it's not going to live here, it's going to live somewhere else. And what I'm going to do is I'm going to paste in that URL that I got from GitHub. And when I paste that in, I'm basically saying, I want you to add the origin as this address. And it's going to go up to GitHub and it's going to find that repository and it's going to say basically, okay, this is the master copy of this folder from now on. So it didn't spit out an error, so that's a good sign. That means that nothing went wrong. So now I can do git pull origin master. And what it's going to do, it's going to think for a second there, and then it's going to say, okay, what are the files that exist on the GitHub version of this repository that don't exist here on the local machine? It's going to find those files, and it's going to pull them down. And lo and behold, if I go back into my folder, where did it go? There it is. You can see that it magically, this README file has appeared. So it has gone up to GitHub. It has found that that README file is the new thing that exists up there, and it has pulled it down into this folder. So now if I go into GitHub, you can see, I have my test repository. It just says this is a test repo. So let's go back here, and let's go into this README file. There we go, and let's open it up with a text editor. I'm going to use Sublime Text. You can use whatever text editor you like. Let's get this out of the way. So here you can see it has all of the stuff that's written on GitHub. And I'm going to take this and I don't want to have this here, so I'm going to delete it. Instead, I'm going to write GitHub is really fun. So now I'm going to save this file. All right, so I saved the file, so I'm done, right? Well, no, I'm actually not done because I saved the file on my computer, but GitHub doesn't know that I made those changes. So what I need to do is I need to commit those changes that I've made on my local computer and then push them up to GitHub. So the first step is to commit those changes in Git. So I'm going to say git add space period. That means add all the different files that have changed. I'm going to type git commit -m added important information. And now you see that Git has told me exactly what has changed, right? One file has changed. I inserted one thing. I deleted one thing. Okay, looks good. Now I'm going to type git push origin master. And it's going to think for a second, and then it's going to push all those changes up there. So now if I go back to GitHub and I refresh the page, Great, so you can see it says GitHub is really fun. So it has added my changes up to that repository. And now if you go in and you look at the commit history here, you can see there's two different commits. There's the initial commit and there's this add and import information commit. And I can browse the code for that initial commit, and I can see, there's the original version of the file, and then there's the current version of the file here. And if I want to, both of these commits have unique identifiers. I can always dial back to the original version of the code, or I can just browse the original version of the code if I like. And if you look at a repository that has more activity over time, let's look at maybe this one. You can see that over time you end up, collecting a lot of different commits that you've made. And so it's useful to leave these comments for yourself, so you can kind of see what you changed each time in case you need to dial back the changes. Let's hop back in to the presentation. So what we just did, we didn't type touch readme actually, because GitHub did that for us. But all touch readme does is it creates a readme file. GitHub gave that to us for free, but you can do it this way too if you want to do it manually. We also typed git init that initialized the directory, so Git started following it. We typed git add. We didn't type git add readme. We typed git add space period to add everything, but we could have typed git add readme and it would have just added the readme. Git commit -n, and we left a comment for ourselves on the line because that's good practice. Git remote add origin followed by the URL, and that was what we used to attach the Git repository to the GitHub repository. And then finally, git push origin master was what we used to push all the changes up into the cloud that we had made and committed on our local machine. So hopefully after that demo, you are feeling something like this. But in case you're not, there are a lot of additional resources available out there. There are some really great getting started on GitHub guides and workflow for beginners and those kinds of things. We will try to leave links to some of those in the description for this video. So that's all I've got. Thanks for watching and hope that was useful.